I think we're about ready. Okay, I think we'll go ahead and get started, maybe a couple seconds early. The speaker this afternoon is Zep of ZepWorks of LA, and he's going to talk about magic today. We all need more magic, particularly after lunch.
Hello, everybody. Thanks for coming. My name is Sep. I'm actually a principal engineer at China. We do online ordering. ZepWorks is my blog. Check it out. So the topic today is magic method on the wall. Who now is the dunder fairest one of all? That's how you read those. And before I continue, I want to warn you that the code that I have here is not for production use. That's why I have a disclaimer here in case you use it to break something. Okay, now that we know that, let's start with some experiments. I don't know about you guys, but I don't like to type too much. Every keystroke is a stress on your fingertips. So sometimes you just want to type A equals A plus 20. And as you know, there's a shortcut for it, A plus equal 20. Now what if we make it even shorter? You just type A plus 20, and there you have the new value of A. Magic methods lets you do that. And you just, by typing less, you save yourself a lot of finger ache in future. Okay, how do we do this? What I hear a lot when I talk about magic methods from people is there are too many magic methods. Yes, maybe, not really. These are all magic methods that are there. And if you take your time and get familiar with them, it's going to help you a lot with creating interfaces. You will learn a lot of syntaxes you see in different softwares, SQL Alchemy, Django, etc., how they did implement it. I really recommend you to look at it. And a lot of them are very intuitive. So, for example, we want to do an add operation. Now you want to override the plus operator. And that is dunder add. So we're going to start from there. We're going to start this mutable integer class called num. We're going to put the value in self. And we're going to use dunder add, which adds the value of the other object to your current value. And we return it. Now that we are there, let's do a little more. Let's also do the dunder sub, which is for subtraction. And dunder repr, which is for representation of your object. If we use this now, we initialize our object. A is 10, A plus 20, the new value of A is 30. A minus 5, the new value is 25. 20 plus A. Oops, you get a type error. What happened here? Let's go back, step back, and look at how magic method works again. For every Let's go here. So we had this dunder add. You add the value of other to your self value. When you're doing A plus 20, you're running the dunder add on A, which you defined how it works. When you're doing 20 plus A, you're running dunder add on the integer object that's 20. And that object doesn't know how to deal with num object that you just defined. That's why you get the type error. How do we deal with this? Did you know that for almost every magic method, there's a reverse magic method too? So, hint, they all start with R. So for R add is for add, the reverse of add, and R sub is the reverse of subtract. How it works is if you have two objects, A and B. If you're adding them together, if it first starts running the dunder add of A. If it can't do it, there's this type error, then it does the reverse add of object B to A. So we can use this R add in our advantage. This is the num class that we defined before. All we need to do is saying R add equals add. And the order doesn't matter, so R add and add are the same, but for subtract, the order matters. So we are actually subtracting the self value from other. Okay, let's run this. So we have A plus 20, A 30, 25, Now it works. 40 plus A, 65. 20 minus A is minus 45. You can continue and play with this, add division, multiplication, all sorts of things. But we want to move on to more interesting examples. Let's try something else. How many of you have used filtered before? Raise your hands. All right, that's great. More than what I thought. That's awesome. So, for those of you who don't know what's filter, you basically pass a condition function that returns true. In this case, we want to get the items that are divisible by 3. So all we want to do when we print bar is to get objects 3 and 6. If you run this in Python 3, what you get is it shows you the name of the generator. In Python 2, you used to actually return the list, so you would get what is inside the list. Now, you might say, I'm going to just run the list of bar, which converts the generator into a list, and that's going to print it. Yes, that you can do that, but I find it a little annoying. When I print something, I want to get the actual results. So how can we modify the built-in filter function so it does what we want us to do? Let's step back and see one of the fundamentals of Python, which is everything is an object. Let's start from here. Let's start with making a simple function. We're going to have this func, and we're going to try to get an attribute of this func. Func is an object. Remember, any object can have attributes. We're going to try to get the underline x attribute of func, and if it's not there, we return not set. Next, we're going to print the new value, which is we just passed x, and the previous value, which is the variable previous x, which we just set. And in the end, we're going to set the underline x of func to be the new x. If we run this, the first time, we're going to get the new value, 10, previous value not set. Next time, we keep track of the previous value of x this way. So what we did, we're keeping the state of something in the function itself. It goes from one run of the function to the next run of the function. Okay, so now that this was an example of how you can add attributes to functions, let's go back to the fundamental thing again. Everything is an object, even the built-in functions. So what if filter, which is a built-in function and is an object, what if we subclass it? Okay, we can subclass the built-in function that's filter, and all we do is add $str and $wrapper. If we run this and we run filter, print it, we get what we want. Okay, I'm going to stop here so this sinks in. We just subclassed a built-in function, and we made it act the way we want when we print the result. Okay, so we're going to move on to other examples. One of my favorite things in Bash is echoing to the end of files. You just echo some string to end of file, adds to it. Did you know that in Python 2 you could do something similar? Just print to the end of file. I never used it, and now Python 3 print is a function. You can't do this anymore. What we're going to try to do is going to try to create an echo object that does exactly what we want. And magic methods are going to help us achieve it. So the operator for greater is the binary operation of R shift. And R shift is right shift, it's not reverse shift. If you want the reverse of R shift, is RR shift. It's a little confusing, I know. So we're going to use this R shift. We're going to start with a file object. We open a file, create this class, get the text and put it in self.text. This is the text that you want to append to the end of your file. And next, we're going to do an R shift, seek the end of the file object, and write to it. So let's run this. You just echo whatever string to the end of your file. It's a legit Python syntax. but don't put it in your production code. It will confuse everyone. Okay. Next, let's do another experiment. One thing that I really enjoy doing in Bash again is pipe and grep. We're going to try to implement this in Python. Okay. The magic method for pipe operator is the under/or. It's another binary operation. Let's use this. We're going to start with a class grep. We're going to grab the item that we want to grep for, put it in self.item, and we lower it. Why? Because I like case insensitive grep by default. And then we're going to try to use the under/or. Now, before we continue, let's think about it. If you use the under/or, this is the syntax we're going to get. You're going to grab something and pipe the text. It's a little weird, it works, but that's not what we're looking for. What we really want is text pipe into grep. And again, the reverse function comes in handy. There's this reverse function, is roar or error, I'm not sure how you say it, but we use this. We get the item, we're going to check if the item is in your line. This is all it does is return a boolean, if it's true or false. Then we're going to have an error, gets the other thing that you're grepping inside it. Checks if it's a string. If it's a string, it splits it into lines. It's a list of lines. And finally, we use the filter method or function that we just made to filter any line that has item in the line. If we run this, these are some lines from the homepage of Python, python.org. We can easily lines pipe grep Python. Not only that, you can double pipe. Gives you a lot of flexibility. I find it very cool. In fact, I implemented this in a library that I've open source. It's called deepdiff. For people who want to search things, there's this functionality there now. Okay, let's move to even more interesting things, the undeletable. For those of you who have ever deleted objects in Python, you're expecting something like this. If you delete a normal object, then you check for that normal object. You get a name error. Object doesn't exist. But what we want to achieve is you delete this magical object. It says, hey, I'm still here. You can't delete me. You check the object. Yes, it is still there. Okay, we're going to try to achieve this. But in order to be able to create this object, we need to understand how delete works in Python. Okay, what happens when you delete an object? And in order to understand this, you need to understand garbage collector. So Python has different implementations. We are specifically talking about CPython. In each implementation, the garbage collector is different. In CPython, how it works is by doing reference counting. And we're going to see how it works exactly by some examples. Reference counting means you have an object. Let's say you have other references to it throughout your code. It counts the number of those references. And whenever that reference count is 0, then it actually goes and deallocates your object. Okay, we're going to try to see this by example. Let's start with a simple class. Again, we have the $str wrapper. We import GC, which stands for garbage collector. And we initialize the object. The function that you use to see how many references you have to your object is gc.getRefers object. And then the length of that response is the number of references. So in this case, we have just one A object. We have one reference. This line, we're going to run it a lot, so let's put it in a function. We're going to define this function called printRefCount. Let's just test it. We're going to run printRefCount A. What do you think is going to happen now? It's going to show 2. We just somehow got 2 references now. What's going on? Okay, let's run the original line again, see what happens. We get 1. What is happening here is when you're running that function, you're passing your object by reference. So inside the function, you have now 2 references. It runs the function. When it's done, now you have 1 reference again. That's how it works. Let's play with this a little more. We're going to have 2 dictionaries that are going to have object A in them. So we're going to run that printf count again, and we get 4. Again, we have 2 references inside the 2 dictionaries. We have 1 reference to the original object, and we have 1 reference inside the printf count. So these are 4 now. And the objects are the same. Let's try to delete A. All right. And then we check D1. Does D1 still exist? Yes, it does. It's the same object. All that has happened is that you remove 1 of the references to your object. So all delete does is removing 1 reference. Now you have 3 references to your object. Going back to why we did this, we want to create an undeletable object. And the magic method that helps us achieve it is called del. We're going to try to see how del plays with this reference counting. Okay, so this was how our object was before. This is how it's going to be after. You're just adding a del. All it does is printing, letting us know when del is running. It just prints deleting A. Okay. We're going to continue where we left. Same object, just has del. At this point, we have 4 references. Then we delete A, we have 3 references. Then we delete C, we have 2 references, and nothing has happened. del has not run yet. You're like, what's going on here? Just forget about it. Exit, and that's when del runs. The reason it ran at that moment, after you exit Python interpreter, is at that moment, the references to your objects are 0. Then garbage collector goes to actually deallocate, runs the finalizer, which is in this case del. In fact, if instead of exiting, here we had deleted D, which was the last reference to your object, it would have run deleting A. So at the moment that you have 0 references, then del runs. Generally, you should avoid using del because you can't guarantee when it's going to run. But in our case, we're going to try to use it in our advantage. Let's go back to what we were going to do. We want to create this undeletable object. Okay. One idea maybe you have is, I'm going to make this del. I'm going to raise some exception. When the garbage collector comes to deallocate the object, it's going to forget about it. There is an exception. It's going to continue what it was doing before. This actually doesn't work, because garbage collector will mute the exception and it will still deallocate your object. Next idea is we're going to try to resurrect our object. So when del runs, we're going to put it back where it was. Okay. One way is doing it is we're going to cheat a little. We're going to know what's the name of the object was. We're going to make this global object that we can overwrite. We're going to set self to object. So we're putting back the object as garbage collector is deallocating it. And then we print, you can't delete me. If we do this, we initialize the object, print object. Yes, it's there. We delete the object, says you can't delete me. Print the object, yes, it is there. This is a great way to introduce memory leak to your work. If you want to test the limits of your application, stress test it for memory, this is the way to do it, but make sure you put some comments there so other people know what's going on. Now, when I came up with this example, I was very proud of myself. I was like, wow, I did it. But then I did a little research and found out that a PyPy core developer in 2008 had a suspiciously similar example in his blog. I was like, wow, he traveled to future, saw my presentation. I don't know how this works. But yes, I came up with the example before I see this. Still, so this one is interesting too. We're going to get back to this article later. Okay, so this is where we left. let's look at the last three lines that we ran. These last three are print the object, delete the object, and print the object. If you run this in Python 3.4 and later, which means 3.5, 3.6, this is what you get. You get the object, it says you can't delete me, it says the object. If you run it in older versions of Python, which is any version 2, 3.3, this is what you get. So why this is happening is that in Python 3.4, there's this PEP 442, that there are some backward incompatible changes to garbage collector. And the idea behind it is that it will run, garbage collector will run dunderdel at most once. So if you can't delete it, then it's not going to try again. But in Python 2, it would try again and then give up. Try again, and finally give up. So now let's have an overview of what we learned. We learned how to do mutable integers. We learned everything is an object, even built-in functions, and you could subclass that. We learned how to echo to file. We learned how to grep pipe in Python. We learned about garbage collector, reference counting, undeletable objects. Now, all of this code is in this package called bad ideas. You can pip install it and enjoy using it. It's very simple to use, from bad import grep, from bad import undeletable. And these are some references that maybe you want to look at. I'm going to have it on the article. So if you go to the article, is exactly the same thing that I talked about. Just go to zepworks.com, which is my blog. The first item is going to be this talk. The code examples are on GitHub. And again, pip install bad ideas. It's a good idea to install bad ideas. Thank you very much. This is good timing. Oh. Oh, wow. They're serious.
Hello. Hi.
Hello.
I feel like I should wait until we're...
I don't think it's going to stop.
What? Okay. So thank you for this talk.
Sure.
I love magic methods. They're the best. So I guess I have two questions.
Say the second question first.
Okay, the second question was, which one is the fairest of them all?
Oh, that's a great question. I don't know. I really tried hard to come up with some examples. I used dunder first. The problem is, like, magic methods are the internal ones. There's no such dunder first one. But maybe somebody should write it.
Good idea.
Yeah.
My other question is, you talked about a lot of magic methods here. Is there one that you wish you could have covered that you didn't?
Oh, yeah. So, for example, if you're ever writing, so I don't know how many of you do async I/O stuff. Raise your hands if you do. Okay. So there's like A enter, A exit, I don't know, all sorts of these new magic methods that are interesting to play around. And I wanted to come up with some examples, but I ran out of time. Yeah, but those are really cool. Definitely check it out. It's a whole different way of thinking when you do async. Thank you for your question.
Thank you very much.
Hey.
Hello.
Thanks for the talk. So you mentioned a lot of these are bad ideas and not production safe. Do you have any suggestions on how to test, or maybe a rubric to use when we are implementing one for production?
Oh, so this bad ideas has unit tests. You can just copy paste those. Yeah, I forget what's the test coverage, but it's not that bad.
All right.
I'm gonna add more. If you have bad ideas, by the way, let me know. I think this is gonna be, you can add more bad ideas there. Because you can always learn from bad ideas, so you don't do them, right? You spot this undeletable in your code now, somebody else put it, you know what's going on. Yeah. Wow, this is still going on. It's good that we're all calm. I guess, did I see another question? Okay. Well, thank you very much for coming. Thank you.
Okay. I think we're about ready. Okay, I think we'll go ahead and get started, maybe a couple seconds early. The speaker this afternoon is Zep of ZepWorks of LA. And he's going to talk about magic today. We all need more magic, particularly after lunch.
Hello, everybody. Thanks for coming. My name is Sep. I'm actually a principal engineer at China. We do online ordering. ZepWorks is my blog. Check it out. So the topic today is magic method on the wall. Who now is the dunder fairest one of all? That's how you read those. And before I continue, I want to warn you that the code that I have here is not for production use. That's why I have a disclaimer here in case you use it to break something. Okay, now that we know that, let's start with some experiments. I don't know about you guys, but I don't like to type too much. Every keystroke is a stress on your fingertips. So sometimes maybe, not really. These are all magic methods that are there. And if you take your time and get familiar with them, it's going to help you a lot with creating interfaces. You will learn a lot of syntaxes you see in different softwares, SQL Alchemy, Django, etc., how they did implement it. I really recommend you to look at it. And a lot of them are very intuitive. So, for example, we want to do an add operation. Now, you want to override the plus operator. And that is dunder add. So we're going to start from there. We're going to start this mutable integer class called num. You're going to put the value in self. And we're going to use dunder add, which adds the value of the other object to your current value. And you return it. Now that we are there, let's do a little more. Let's also do the dunder sub, which is for subtraction. And dunder repr, which is for representation of your object. If you use this now, we initialize our object. A is 10, A plus 20, the new value. I just want to type A equals A plus 20. And as you know, there's a shortcut for it, A plus equal 20. Now, what if we make it even shorter? You just type A plus 20, and there you have the new value of A. Magic methods lets you do that. And you just, by typing less, you save yourself a lot of finger ache in future. Okay, how do we do this? What I hear a lot when I talk about magic methods from people is there are too many magic methods. Yes,